Hi viewers, as promised, we have reached to the point of talking about the rules for differentiation. The first one we'll be talking about is the product rule. So we all know what product means, right? When we say product, it means two things are multiplying themselves, right? So recently we were talking about just function, just y equals x squared, right? If you've not watched the video I made on the introduction to differentiation, then I'll be dropping the link in the description so you can watch the video on how to differentiate a certain function of this form. So as for today's own, I'm going to talk about the product rule. So when we have a function just x squared, this is just a polynomial, right? A quadratic equation. So when we have, let's say y equals, let's attach x with a trigonometric. We have sine x, and we all know that sine x is a trigonometric function, right? I've mentioned so many functions in the last videos we've made. So this one, I'm having two functions, right? I have x and I have sine x. We have a polynomial and we have a trigonometric. So how do we solve this kind of function? If you are told to differentiate this now, it's a very confusing stuff, right? So, but calm down. That's why you are watching this video. So the first thing you have to do is, I'll just the formula you use for the product rule. I'll just write it now. The y dx is u dv over dx plus v du dx. In case you don't know, you are supposed to know how to derive this formula, right? But I will not be making the video again because I've made that video already. I will also drop the description on how to the video of how to differentiate or derive this very formula, which we call the product rule. So as you can see, we have u, we have v, we have dv, we have du. You'll be like, but you are not seeing u and v in the function given. Why am I introducing u and v? The thing is, this function is given in the form y equals uv, right? Where u is a function of x, v is a function of x. Clearly looking at this, you can see that x is already there, right? X should be our u, then sine x should be our v, right? So in case you are still, because differentiating trigonometric functions is something tricky and confusing because most students do find problem with how to differentiate trigonometric functions. So, but I've already made a video on how to find how the shortcut on how to even I should I say how to cram or memorize how to differentiate a trigonometric function. So I'll also drop the link in the description on how to differentiate trigonometric functions. So for this very one, we said our u, because I'll just solve this question directly, right? So our u, we let our u, I'm trying to solve this very question. We let our u equals, let's call it x. Immediately you are done with finding your u, you can see we need du in the function. And du means what? Derivative of u with respect to what? X, right? So if you differentiate x, recall from what I said in the past video, right? I said the derivative of just a single polynomial, like x is always 1, the coefficient, right? And as you can see, the coefficient of x here is what? 1. So our du dx is equals what? 1, right? So that means we have u, we have du. The next thing is to find our v and dv. So looking at the function, you can see that v is what? Sine x, right? So we have v equals sine x. So what is our dv? Because we need dv in the formula as well, right? So if you uh if you watch the video I'm talking about on how to differentiate a trigonometric function, you will find out that the derivative of sine x is always cos x, because I even made a shortcut on how to find such derivative, right? So we have u, we have du, we have v, we have dv. The only thing left is to substitute in the formula, right? So our dy over dx is equals u. Our u is what? X times we have dv dx. Our dv dx is what? Cos x, right? Cos x. Then we have a plus v. Our v is what? Sin x multiplied by, you can see we have du, right? Our du is 1. So if you write this, we are going to have x cos x plus what? Sin x. And this is the derivative of this product of the two functions here being product of themselves, right? You can have not only this, you can even have exponential functions, right? But I've not yet made video on how to differentiate exponential function, which I'll be doing soon. But that's just how to differentiate a uh, a product rule. So let's still form one more question so you understand it the more. When you have let's say y equals let's use two trigonometric functions at the same time, because you can also do when you are given a function, let's say x cubed. You all know how to do the shortcut to differentiate this function, right? But if you want to like stress yourself or make things look more okay, as you can make it like x squared times x. Then you use this formula and you are going to have the same answer as when you bring down the power, subtract one from the power. But this is very stressful. At least you know how to do the shortcut. Why suffer yourself, right? So how about this type? We have sine x, cos x. So this one, you just let your u equals the first function, which is sine x, right? Immediately you're done with finding u, I said you go for your what? Du dx, right? Du dx is what? Derivative of sine x, we said, is cos x. So immediately you are done with u, you are done with du. The next thing is to find your v, right? V is what? Cos x. So what is our dv? Because immediately you are done with v, you find dv. So dv dx is equals, if you differentiate cos x, you are going to have minus sine x, right? So you can see everything is set for the formula. So the next thing is to just substitute in the formula. So dy dx equals, we have u dv. What is u? We have sine x multiplied by dv. Our dv is minus sine x. So you put minus sine x, right? Then we have plus, what is v? We have v, which is cos x, right? Times, what is our du? Du was cos x, right? So if you are to expand this, dy dx equals, because that's the only thing we did in the formula. So we have a minus sine x in the bracket, right? The next thing, if you want to solve this kind of thing, is to bring out your negative sign, which is minus sine times sine is sine square x, right? Then plus cos times cos is cos square x, right? So from this point, I don't want to leave my negative outside. So I can just rearrange, right? So this is going to be cos square x minus sine square x. There's an identity for this function, but for the sake of this video, I won't be talking about identities of trigonometric functions. You can just leave your answer here and that's it. That's how easy it is to differentiate functions being product of themselves. There's a shortcut on how to do this actually, because you can see it's just like keeping the first, differentiating second, plus keeping second, differentiating first. I will make a video on how to differentiate, or should I say the trick to differentiate product rule, right? So that's it. I hope the video was very okay and simple, understandable. Don't watch out the next video, because I will also be making videos on more of the functions we spoke about. Please don't forget to comment, subscribe, share, and like the video.